Ladies and gentlemen, here's the video for topic 1.2 and topic 3.3, water quality and living things. I've combined two sections just to speed us through the unit. All of this can be found in your textbook on these pages. So we're going to start by talking about water quality. Water quality describes how pure water is. Okay, so the purer it is, the higher the quality. You determine water quality by measuring the amount of substances that are in a sample of water. So scientists would go out, they'd collect a sample of water, and they typically would take it to a lab, and the lab would test it. When I worked out in the field, that's what we did. There was very important procedures to taking samples of the water quality. If you messed it up, you could have potentially damaged the whole entire sample. Do you think we have good water quality? Yes or no? Yes or no? You're thinking, I'm not sure. We have really good water quality. Okay, Airdrie, Calgary, we have really good water quality for a few reasons. Number one, we've got some of the best water treatment plants in, well, if you ask the water treatment plants in all of the world, but we definitely have some of the best water treatment plants out there. And secondly, we're very, very close to our source of water. Our water comes from up in the mountains. So because we're so close to the mountains, because we're so close to the source, there's a lot less opportunity for the water to get polluted as it moves across the country when it's with us. So substances get dissolved in water. These are some of the things that people actually worry about. So most of the substances that are dissolved in water are called salt. Okay, um, they're called salt, and it's in fresh and salt water. Fresh and salt water. The total amount of salt, I'm sure you guys have heard this term before. I think we talked about it in the first unit, is called salinity. So the measure of the salinity of the water sample determines how much salt is in the water. The average salinity of seawater or water out in the ocean is 3.5%. So 3.5% of it is salt. There are other substances, however, that dissolve in waters like silver and gold. You can make millions and millions of dollars there, but it's so little and it'd be too expensive to process them. So don't have to worry about those. We're going to talk about hard water. Hard water is something that definitely affects us out here. Salt and other minerals that run off in the Earth's surface and underground have an effect on water quality. Many areas across the country have hard water. So hard water is where your water contains too high or contains a high concentration of minerals, and the minerals are calcium and magnesium. So if our water has too much calcium and magnesium in it, it is called hard water. So do you think we have hard water? Take a look at this picture. Have we seen this before? Okay, so something like this is the buildup of minerals and whatnot underneath your tap. Does not mean it's dirty. Does not mean you're dirty. Does not mean that it's going to be very harmful if you're drinking it. But yeah, we do out here have hard water. You can tell you have hard water if you end up by getting these types of deposits on your faucets, on your showers, the bottom of coffee kettles, those types of things. You can also get it if your soap doesn't lather up that well. Okay, so if you have soap that doesn't lather up, it's not very sudsy, you don't have the big bubbles in your bubble bath, those are all signs of hard water. This can actually build up in your hot water tank, and it causes a leakage it causes your hot water tank, sometimes the overflow valve, it causes it to leak or drip. And it's actually a very cheap fix to go and fix it yourself, but a lot of times you end up by having to go and pay a repairman to come and do it. So the other thing we have to worry about are organisms in our drinking water. Fresh water also contains organisms and other organic matter. So just because the water is fresh does not mean it doesn't have organisms in it. And here's some beautiful pictures of some organisms we might have in our water. Okay, most health problems that arise from water quality are due to a microorganism called E. coli. You might have heard of this before, the E. coli in the water, E. coli poisoning. This little model here is a nice little representation of the tiny little E. coli. It's so small you obviously would not be able to see it in your water. So the solution for this is treat. They usually get treated at water treatment plants. So when the water goes through the water treatment plant, the water treatment plant will eliminate the E. coli, the bacteria. But there have been cases where the water treatment plant was unable to clean it for one reason or another. So they would put into place a boil order effect so that you would heat up the water and it would kill any of the microorganisms. I went to the water treatment plant a few years ago, and they said that there has not been a boil effect in place for Calgary for many, many, many years. So that's a good sign about our water treatment. However, when we had that flood a few years back, there was warnings that the water was going through too fast, that they would may have had to institute the boil water effect. But I don't think it actually happened out here. But every now and then you'll hear about it in outlying areas. So water quality testing, this is something that, like I said, I used to have to do. Water from a well. So we talked about groundwater. When I said talked about groundwater, I was talking about water way, way deep underground, like in a well. Those usually have some of the cleanest, nicest water. My grandparents used to have it out at a farm. You'd turn on the tap, the water would come out. It was so clean, it was so fresh, it was so cold. It was the best water in the world, and it came right from the ground. There was very, very few pollutants, if any, in that water because it's protected from the ground. There's a lot of space between the ground and the water to protect it from any pollutants. We, however, get our waters from surfaces like lakes and rivers. And you guys have driven by lakes and rivers, driven by the canals and whatnot. You see all the things that run into it. So the water that we get that comes to our house gets filtered and treated at a water treatment plant. A few years ago, I was able to take my grade 8 students to a water treatment plant, like I said before, and then it gets transported to our homes. This water is tested regularly. There was a person that was at that treatment plant that his sole job or her sole job was to check on the water. And I think they checked on it every hour or every 2 hours to make sure nothing happened because the water was constantly going through. Pretty cool process. So water is tested for all of these things. Some of these things might seem gross, and a little bit they are, but these are things that are tested. Water quality testing is taste and odor. So they'll taste it, they'll smell it. You wouldn't want to drink water that has an unpleasant smell to it, and you wouldn't want to drink water that has a bad taste to it. Turbidity. So that's the cloudiness of the water and the color of the water. So it could be because of numerous reasons. It could be because of particles that are floating around. It could be something else that's inside of it. Toxic substances and other pollutants, so things that are poisonous, obviously. Bacteria, we already talked about E. coli and other tiny little microscopic organisms. Hardness and mineral count, we talked about that. pH, how acidic or basic the water is. Typically, we want our water to be about a pH 7, right, neutral. Dissolved oxygen, and this one's really, really important. If you think back to the first unit, we talked about how concentration of oxygen actually decreases as the water temperature increases. As the water temperature decreases, the oxygen concentration increases. So the colder the water, the more oxygen it can hold. And solids, including floating materials, and also dissolved solids. So the solids, including floating materials, could be anything. Could just be like sticks floating in the water and little dirt particles. Could be feces. Okay, and there's feces in the water. And then dissolved solids are things that have dissolved solids like salts and sugars and things like that that have dissolved in the water. All of these, if we were to take our tap water to the water treatment plant, all of these things would be looked at, and we would get a big report back saying what the percentage and exactly the descriptions of all of these are. Changing salt water to fresh water. So we talked about, we did the last lab, and we discussed whether or not we need to be worried about the amount of water we have on the planet, how much fresh water we have. And some of you said, I'm sure, said yes, we need to worry about it. Some of you said no, we've got lots of water. Like even though it's only 0.0003%, that's still a lot of water considering how much water is on this planet. And both of you have fair arguments there. But the big argument about saltwater, freshwater is, well, we have all this salt water. Why don't we just go and change it? Okay, why don't we just go and take this salt water and make it to freshwater? First off, is that possible? And the answer is yes. Yes, it's definitely possible. Okay. Next question is, well, why don't we do that? And really, right now, there's no need to. Okay. The reason we don't do it is because there is no need to. There is a lot of fresh water on the planet. But if we did have to, how can we go convert fresh water to salt water, or sorry, salt water to fresh water? There's two methods. The first one is distillation, and the other one is reverse osmosis. And you've probably heard of both of these before. Distillation, think of distilled water. For all of our labs that we did, Miss McDonald set it all up so that even though we didn't have to, we used distilled water just to make sure all the impurities, the water was pure and all the impurities were removed. Distillation involves taking it, it's taking the sample of water and boiling it. Okay, so the water, we heat it up to the point where it boils, and once it boils, it turns into a vapor. Okay, the water itself turns into a vapor and moves. Okay, so that water vapor moves typically through a tube to another area where it's allowed to cool down. Well, what happens when you take hot vapor and you cool it down? It condenses back into a liquid. So that salty, dirty water evaporates, moves up into a collection chamber, goes through a tube, collection chamber, where it cools down, is allowed to condense, and then you end up by getting some nice fresh water. Okay, and I'll put a video or two up of distillation. Okay, what are some drawbacks of distillation? What are some benefits? Well, benefit obviously is it does take the water and it changes it from fresh water, or sorry, salt water to fresh water. One of the drawbacks, it's going to use up more natural resources. We need to heat that water up. Okay, we need to take that water, heat it up, and move it from one process to another, and then cool it down. So in order to heat it up, you need a natural resource. You typically need a heat source. To cool it down, you need some sort of cooling device. You want to do it in a relatively quick process, so you don't want it to take too long. So you'd have to use more natural resources. Using natural resources costs a lot of money, right? The other thing is it does take time. It is a time-consuming process, so it's not like that you can get fresh water. Reverse osmosis is another device or another method of taking salt water and converting it to fresh. And we talked about osmosis before. Osmosis is the movement of particles from an area of high concentration. Sorry, osmosis is the movement of water particles from an area of high concentration to an area of low concentration through a selectively permeable membrane. Reverse osmosis is the opposite. We take salt water and we force that salt water through a membrane with holes that are too small for the salt particles. So we're taking something with a low concentration and we're forcing it through something into a higher concentration. So it's the opposite of osmosis. And in order to do this, excuse me, you need to have, again, energy source. So it is not very feasible to do something like that, especially with the amount of water that is on the planet. Someday will these be life-saving methods and ways of surviving? Maybe, but right now we're doing fine. So again, I'll put a couple of videos of these on D2L. Please make sure you watch them. They shouldn't be too long. Okay, so this is the opposite of osmosis we talked about earlier. Particles are being forced from an area of low concentration to an area of high, and it requires energy to work. So this goes on to topic 3.3, where we talk about water quality and living things. And obviously, water quality can affect living things. So we're not talking about us per se now, we're talking about the things that live in the water. Okay, so water quality changes can occur over a relatively short time, or it can be many years if this happens. Okay, and the textbook uses an example, which is actually I've seen in my lifetime, where some of you might have remembered it. Think of a lake that you used to go to when you were younger and whatnot, and when you were there younger, you saw fish darting all over the place. Okay, and then over time, you'd go and there'd be less and less fish, maybe less and less wildlife. Maybe the water started to smell, things like that. Okay, so you can argue that's a short time, you can argue it's a long time, but either way, it can happen. Some of these changes can be reversible, some of them cannot. Okay, some of the biological indicators that tell us whether or not a water body is going down is the organisms that are actually in the water body. So the more organisms, or the more different types of organisms that are in a water body, the healthier that water body is. We're going to talk about that a little bit more in topic 2. Typically, the more diverse the number of organisms, the healthier it is. I remember one lake we went to check that I did a survey on. I believe it was called Lake Normandeau. It used to be a trophy fishing lake, and when we went there, all we were able to sample, all we were able to catch were these brassy minnows and long-nosed dace. And long-nosed dace are typically this big, maybe typically like this. The ones we were catching, they were like this. Okay. Once upon a time, there were a lot of game fish on this lake. The game fish all died out due to the water quality changes. Okay, because the game fish died out, the minnows that typically would be this big ended up by getting to be about that big. They were like trophy minnows, if there's such a thing. The other thing that was in them was, I said there was brassy minnows. Just a tiny little minnow. They're kind of a brownish color, very pretty minnows. But who cares? They're just a minnow, right? The sad thing with those minnows was Lake Normandeau, I believe it was called Lake Normandeau, the lake that we went to, that was the only lake in Alberta that had the brassy minnow. So there was lots of them, lots and lots of them, but the water quality was going down. We knew that over time, those fish, they were going to die out because the water quality would be too poor for them as well. And then that would be a wipeout of a whole entire species of fish in a whole province, right? Typically, not a minnow is not something someone worries about. They think, oh, just a little minnow fish. You don't mount those on the walls. You don't eat them or anything like that. So it wasn't a big deal. But the water quality on that lake ended up by decreasing over many years and wiped out all the game fish and just left those guys. So increased substances can have negative effects, obviously. Okay, so an increase in the acidity of a water body can obviously wipe out entire lakes. Fish typically like a nice neutral water body. If there's pollution and whatnot from factories that get up into the air, then that mixes in with the clouds and whatnot and causes acid rain. Well, that acid rain falls down, obviously, and gets into the lakes, and that increases that pH level. Even small changes in pH levels can have drastic effects on lakes. So if the pH level goes up or down, even a little bit, it could potentially kill out a whole bunch of the different fish and species of organ or animals that live there. So that's obviously an issue. The other issue that we see a lot are algal blooms, and some of you may know what an algal bloom is, some of you may not, but it's when you get a whole bunch of algae on that particular lake body or an area of lake. It's called cyanobacteria, and that algae grows at a massive rate, and it has a very pleasant smell. I'm being sarcastic, and it actually has toxic properties. So you could get very sick in it. Animals will die if they drink a lot of the water, and all of that happens because of the increase in the water body. Or increase of nutrients in the water body. So it's typically us. It's typically us that cause it. So an increase in fertilizers, either for properties like here at home or fertilizers in farmers' fields. I'll just draw you a quick little picture. Let's see if we can do this. I usually have a fun little discussion in class with this. This is the one where I kill your dog and stuff like that, but I'm not going to do it here. So let's see if I can draw this. So let's say, imagine this is our nice little lake here. This is land. Okay, so I usually say we build a nice little house here and plant some grass here. So this is your big shoreline. Okay, we have all this water along here. Okay, so we have all this water, and you end up by having down in here, you have weeds, which are nice. They're good, provide oxygen to the water. Okay, and of course we have fish. Sorry. Okay, these are my fish. Okay, so we got a bunch of fish, bunch of weeds, and then the way the cyanobacteria works, cyanobacteria, it's actually very natural. So you have some little bit of cyanobacteria right there. It starts growing, but you have all these farmer fields all around all around the lake. You've got these houses around the lake. Of course, you're going to fertilize your lawn so you get nice green grass. Well, that fertilizer runs off and it goes in here. What happens to the weeds with fertilizer? Do you think they like it? Of course they like it. More weeds start growing. It's perfect. Okay, so you get more weeds, and then you end up by getting the bacteria growing around here. Okay, the bacteria goes and it covers the surface of the water. Okay, and not pleasant. You don't want to be swimming in that, but everything's okay here. Don't have to worry too much about it. The fish are happy. They're getting lots of oxygen. The sunlight starts to like late in the summer. The sunlight doesn't penetrate the weeds, so you don't not typically not fertilizing late in the summer. So when the sunlight's not fertilizing the weeds, some of these plants may die off. Okay, because they're not getting enough energy from the sun. But that happens. It's not the end of the world. So we get some dead plants down here. Well, what happens when the plants start dying? They start decomposing, and when you start decomposing plants, they start producing carbon dioxide. Okay, so carbon dioxide, the concentration of oxygen down here goes down, but it still gets mixed in with the wind and whatnot. So it's not the end of the world for the carbon dioxide. The fish, they're still happy, they're eating each other. But then September comes around or October and we get a nice little cold spell. So you haven't been able to play in the lake or whatnot for a little bit because of this algae. But you get that cold spell and boom, the algae is gone. Perfect. Okay, the algae is gone. We're back to nice fresh water. Where'd the algae go? It's sunk down to the bottom. So now we have algae down here. We've got dead plants down here, and it's all rotting. Okay, this happens every now and then. It's totally normal. Well, not normal, but it happens. Winters come and go, and this process occurs like maybe 3-4 years in a row. Okay, so if this happens 3-4 years in a row, we end up by getting a bunch of buildup. Okay, and let's say year number 5 comes along and we've already had the algae buildup, we've had the weeds grow every year, die every year around September, start decomposing. The algae grow every year, die every year, starts decomposing. Let's say winter comes around. Okay, winter comes around, that fish got stuck in some ice. We end up by getting ice now. Okay, so the ice is going and it's covering the lake. Okay, and this happens every single year, but now we've had about 4 or 5 years of algae, dead algae buildup and dead weed buildup at the bottom of the lake. We start getting, it's starting to decompose. What's happening to the concentration of oxygen in the water. The fish are using the oxygen, and as the fish are using the oxygen, the weeds and the algae and whatnot, they're producing carbon dioxide. Okay, what ends up by happening if you have massive carbon dioxide buildup and not enough oxygen buildup? Our fish start dying. Okay, so we end up by getting all these nice little fish, and they all die. Okay, that's awesome. It's just super sad. Okay, and then May comes around or April. What happens to the ice? Well, the ice goes away. We have water here, and what's floating in the water? We get seagulls all over the place, and we have all these dead fish floating on the surface. Okay, that's called winter kill. Something like this happens. Something like this happens naturally on lakes probably every 20 years or so. It's a total natural occurrence. However, the problem is a lot of the lakes that we know out here, this actually occurs possibly every 5 years or so. Listen to the news every spring, and it's springtime now. You might have heard some of it on the news. I know lakes like Lake Isle, it's very common. Pigeon Lake, Gull Lake, Wabamun Lake. It happens every five years or so. So yeah, you get a big, massive winter kill, and it's all because of the increased amount of nutrients in the water. So that's it. It would have been so much more fun in class. I would have had you married. I would have married a couple people off and got them divorced, killed your dogs. It's a fun story, but we're at homeschool. I can't do that. So that's it. If you guys have any questions, application questions are going to look a little different for this section because I'm going to throw some from topic 3.3 in there. And then, yeah, that's it. Have a good one, boys and girls.